Okay, here's one that's going to be probably kind of tricky for everybody. This is a buffer solution. So we have a buffer. This is our acid part of the buffer. This is our base part of the buffer. So that's acid because it starts with hydrogen. This would be its conjugate base, but it doesn't really matter. So we want to know the pH, and we're going to add solid NaOH. And we're given a Ka. Okay, so when we're dealing with the buffer, let's kind of write out what's happening, okay? So we know that in a buffer, we have HF, and we're in equilibrium here, and it's going to break apart in, there we go. All right. So now we have to make a Bca table here because this is our stoichiometric calculation. So we need to, this time, we need to figure out our moles. Fortunately, our concentrations here are equal, so that helps. So we need 0.25 molar times 1.5 liters. If you don't do this, you're going to be sunk. 375 and 0.375. And this is moles, not millimoles, but it doesn't matter because they're the same. Okay, now think about this. NaOH, this is a base. The base reacts with what part of the buffer? I sure hope you said, Dr. B, it reacts with the acid. Acids react with bases. So there's this. So here, now I'm going to leave it this way. So we're neutralizing the base, so we're going to use the acid. And it tells us how many moles there are. So we're using acid. We're losing acid. And that acid is becoming conjugate base. So 0.275, 0.475. All right. So let me just kind of go over here and say HF plus OH minus is going to make water and fluorine. So maybe you like that better. So if I do my Bca table here, I'm going to write it this way. Just another way of doing it. Water doesn't belong. I just kind of do that in my head. Okay, so we have 0.375, 0.375. Here you can put 0.1. We're going to lose that because it's going to be neutralized. And that means it's gained over here. So that goes away. That should always be 0. So you go, oh, one of these goes away, just like in a titration. All right, so either way you get it, you should be figuring this out. Now, pH in a buffer solution is pKa plus the log of base over acid. That equation will be provided to you. So let's go over here. Let's figure out what's pKa. That's going to be the negative log of our Ka value, 3.5 10 to the minus 4. So 3.46. So our pH is 3.46 plus the log of our base, which is the fluorine, over the acid, hydrofluoric acid. Oh, that's a 2. You can't read it. 0.275. So 3.46 plus the log 0.475 over 0.275. 3.7.